Right, here we go. We're going to look at this question we've done before. I'm going to try and find an equation for this line here. And we're going to use this line, first of all, to find points. Because the key thing to find in the equation of this line is to find this point. We know this point. It's given, not given to us. Okay, so we're not going to do it that way. It's a different question than what I'm thinking of. So we don't know that point. We don't know any points on M, but we can find, because we know that M is right angles to here, we can find the gradients at M very simply. So that gives us one thing we know. And we will be able to find the point where these cross. Okay, let's go through that. So the first thing that we're going to do is use this equation here to find the gradient of the line L. And then once we found the gradient of the line L, we can find the gradient of the line M. So x plus 2y equals, I'm just going to get my fatter pen. So 2y equals minus x 12. Divide throughout by 2, I get minus a half x plus 6. So the gradient of line L is minus a half. Now the gradients must times together to equal minus 1 because they are at right angles to each other. Okay, when they're at right angles to each other, the gradients must multiply together to give us minus 1. So minus a half is the gradient of line L. Okay, and we want to times that with the gradient of line M to get minus 1. So therefore we get M by doing minus 1 divided by minus a half, which equals 2. Turn it upside down and multiply by the reciprocal. Let's just go through that. Minus 1 times by minus 2 over 1. You can turn this fraction upside down here and then multiply. And that gives us 2. Only looking 2. Let's get the right pen. So we know the gradient of our line. Now, we can find this point because we know that AE equals EB. So this distance here, rub that out, this distance here is the same as this distance here. Now, if we know those two are the same distance, we can find that point, and then we know that this triangle will be the same as this triangle. And then we can find the x-coordinate of A, and we can find the y-coordinate of A using that idea. So first of all, we need to find out where it crosses the x-axis. So it crosses X. So which one is this? This is line L crosses X when y equals 0. So we put y equals 0 into this, and we get x plus 2 times 0 equals 12. So x equals 12. And we know that it crosses y when x equals 0. There's another way to do it, but we'll just do the x equals 0 way. So we get 0 plus 2y equals 12, so y equals 6. So we now know that this point here is 12, and we know that this point here is 6. So if that goes 12 along and then 6 up, then this is going to go 12 along, and it's also going to go 6 up. So that point there will be 12, and this point here will be minus 12. So we know the coordinates of this point here is going to be minus 12, comma 12. So if we use y minus b equals mx minus a, where AB is a point on the line, so we got y minus 12 will equal m, and we know our m is 2 times x minus minus 12. That's an equation of our line. And to just finish it off, we could probably simplify that a bit. I'm running out a bit of screen. Let's just see if we can get that on screen. So we get y minus 12 equals 2x plus 24. Minus and minus gives me a plus. Times by 2 is 24. And I'm going to add 12 to both sides to get y equals 2x plus 36.